On like the 3 meters, how high is it?
1 meter. So it's right here. It's what water I have, right? Okay. So what's the volume of the whole pool? Well, I have this slab on the top, right, which is a rectangular solid, which would be 1 by 6 by 12, right?
Okay.
6 this way, 6 this way, 12 that way, 1 up and down. Okay? And then plus, I have this triangular piece, right, which is going to be a triangular solid, right?
Yeah.
And so that would be 1/2 the base, which is a triangle, which would be 1/2 2 times 12 times the direction this way, which is 6. So that'd be the volume of the whole entire pool.
Can we write those in meters?
We can in a moment. We'll have to define what those letters are, and we're going to have to. Why are they making you find the percent of the pool? So you can start finding the equations, what they're going to do here. So what's the volume of the water, though? The volume of the water is, it's got a height of, so it's also a triangular solid, right? So it's going to be 1 by, how far does it go this way? There's only 1 meter deep. 6, right? Everybody see that? So 1 by 6 by 6, or 1/2 that, right? Because it's a triangle solid. So I get, currently there's 18 meters cubed of water. And whatever this is the total water. So that would be 6 times 12 plus 0.5 times 2 times 12 times 6. Is 144 meters cubed. So the percent filled in would be 12.5% of the pool is filled in. Now again, all that's an exercise to do what? Start thinking about the equations. We're setting you up for, hey, you learned this in geometry. Now they're going to ask the question, right? That's probably the HDT, right? What is the rate at which the water level is rising? So you ask the HDT. How fast is the water going up as I pour water in the pool at that moment?
Wait, why is it 1 times 6 times 12?
Because the water is only 1 meter deep. Oh wait, what are you talking about? This one?
Yeah.
That's a slab on the top.
Okay.
Remember, it doesn't slant all the way to the edge of the pool, right? There's a 1 meter drop off at the very beginning.
Okay. I just got a different answer. I don't know what.
I don't know.
I got 132.
You're missing 12.
2 times 10 times 6. Oh.
2 times 10. Where do you get the 10 from?
This fantastical land called Mystery Land, and
Okay.
From there.
10 should be in your equation. Draw a picture, right?
Yeah.
I'm going to draw myself a picture. Here's my picture of my water. Looks like this. Great?
Yeah.
All right. I'm dumping more water in. Water's coming in. Into the pool. What do I know?
We know that it's like there's like a meter of water.
So this side is going to be 1 meter. So the height is 1.
And the length is 6.
You're going to call this length, so I'll call that length, and I'll say that's also 6 meters. Excellent. Oh, wait, which way do you mean? I may have jumped the gun there.
What do you mean?
Okay, so 6 this way. What's this dimension? That's 6 also. I just want to make sure I didn't jump the gun there. Okay, good. We've got the dimensions of that done. What do we know about how the water's changing?
It's changing at 1 cubic meter per minute.
And what letters would I use in front of that associated with it?
DR.
No. You said cubic meter, didn't you?
Yeah.
That implies a different letter. Cubic meters. B, we're talking about volume, right? How much water is being poured into the thing, right? So dV dt is equal to 1/4. It's increasing, right? Not draining?
Yeah.
So it's going to be positive. Cubic meters per second? Minute?
Yeah.
Second.
Per minute.
Per minute. Okay. Per minute. Okay. All right, so that's how fast we're filling the pool. Anything else we know like that?
Like, there's no other.
The doors. See, actually, what the real problem is when you close the door, and the next person goes out and they leave it closed, and then they're upset that I closed it. Thank you. Okay, what am I solving for?
You're solving for like how much water is in it.
No.
Oh wait, no. Oh, sorry. The rate at which the water level is going.
Water level, what is that in terms of our variables? Because this was H, L, and W.
Water level.
What's water
That
level?
would be like height.
Height. So dH dt, right? That's what we're looking for.
Yeah.
So you need an equation that writes V, H, and possibly L. Or W. And H. Well, I need an H and a V, certainly. Give me an H and a V equation.
Each
Has V and H in it.
volume of a triangle.
Right, a triangular solid. But that's why they set the first part of the problem, right?
Yeah.
Aha! So we're going to go volume of a triangular solid, which in this case would be 1/2 the height, right, times the L, that'd be my triangle,
Yeah.
times the width. Should that mention that way?
Gotcha.
Now, Ms. Sachs said earlier, this leads to a product rule from heck. Why? Because I got 3 variables there.
Yeah.
That's going to make the whole thing blow up in my face and make me cry and stuff. I don't want to do that. If I can find, is there any of those 3 variables that is not going to change during the whole entire problem?
Like the width.
The width is not going to change. So I can make that a 6 right away. So I can take the width and make that a 6, okay? So the volume of a triangular solid would therefore be 6 times 1/2, right? Would be 3HL. Yes, ma'am?
Why are you adding on the first part?
Because the first part has no water in it.
Oh,
I'm just tracking the water. So I've almost got this home. Almost got it. Is that a good enough equation? Should we use it? Okay, it's not going to work. I'm going to go ahead and use it. I wanted to show you something. It's got a dLdt in it. We don't have a dLdt. We know we don't have that, right? So we're going to have to sub it in at some point. But we didn't know that, so we're going to do it wrong first. Fair enough?
Okay.
Okay, let's do it. Yes, ma'am.
don't they have to give us some kind of point? That was-
Yes, they said for 1 meter deep. Yeah. They give us that at least. All right, moving forward. So I go to VDT. 1 out in front equals 3H times 1 dLdt plus 3 times L dHdt. I wanted to find this one. I have this one. What am I missing? Missing dLdt. Can't do it. This problem's undoable now. Need a new equation. Can you mutate this equation to something useful? Now, so far the trick has always been, can you tell me this in terms of this? H in terms of L, or L in terms of H.
Yeah.
How are they related?
Well, let's wait. How are H and
L related.
Like the 3.
The 3 in front? No, that's part of the volume thing. When we first started this problem, we said this was 6 meters from across here. We filled it with 1 meter water. How the heck did we come up with that? I mean, just off the top of your head, wow, it's 6 meters across there.
Because it was halfway across.
Halfway across. What if it was only a 1/2 meter deep? Well, how much water would be in the pool?
A third. Right, 3.
3 meters, right? So 6 times bigger, right?
Yeah.
So this dimension, this L dimension, is always 6 times bigger than my height, right?
Oh, yeah. Okay.
So my height, 6 times my height is my length, agreed?
Yeah.
Now again, I can do it there, substitute it in, or I can simply get rid of length altogether, which is what I'm going to do. So my new volume equation, or my triangle, prism, solid, whatever it's called, is 3h times 6h, right?
Yep.
Or 18h squared. So my volume would be 30, oh, I'm going to take my derivative now. So dv dt will be equal to 36h dh dt. So that gives me 1/4 equals 36 dh dt, or 1 over 144 feet per minute. Oh, not feet, meters per minute, sorry. Meters per minute. This is why when you first fill a pool, it looks really good at the very beginning. And then as time wears on, you realize your pools are never going to get full of water from that garden hose.
Is that how you fill yours?
Yes,
With the garden?
the garden hose.
Okay.
Basically, I throw it in there one morning, come back the next morning, it's about half full. The trick is you can't let it go too long. Our